Alright guys, welcome back. Today we're going to look at two big questions. The first question is on your booklet, question number 4, page 139. We have two people competing, okay, over d meters. We don't know what d is, so we're going to figure it out. Part A, we need to draw the speed time graph. Okay, notice that it's a speed time graph, it's not a distance time graph. So just because this is probably the first time that we draw a VT graph, so I'm going to go over the whole thing with you. So we put V over here and T over here. Let's start with Sasha. So Sasha accelerates from rest for 6 seconds to a speed of 8. We only know that we're accelerating all the way up to 8 for 6 seconds. 6 is over here. We're supposed to go all the way up here. Okay, so that's what we get first of all. And then we remain the same speed for 40 seconds. That means we need to go all the way up to 46 seconds, and then we remain that speed. Notice that in this case, the flat line doesn't really mean that we're resting. It means that we're remaining the speed of 8 meters per second for 40 seconds. Okay, and then at the end, we are decelerating at 4/7 meters per second until we stop. Okay, so at the end, we need to go back to velocity equals to 0. This is basically telling you the gradient, actually. It means if we are decelerating at 4/7, that means our gradient is minus 4/7. Okay, so on the graph, if you minus 4 from 8, right, so from this point, if we subtract it by 4, that means you're going to go down 4 here. So down 4, right 7. Right, so this is 46. If you plus 7, that means we're going all the way to 53. Okay, so 53 is over here. This is 52, and then this is 53. Okay, so if you connect that all the way through, you will see that you actually happen to hit velocity equals 0 at 60 seconds. So that's Sasha. For Kim, we're going to do the same thing, except we are accelerating from rest for 4 seconds up to a speed of 8. So this is a little bit different. So that means by 4, you will get to 8 already. So the first part looks like that. And then we remain constant speed until 44 seconds. So 44 is over here. And we connect it through like that. Finally, we are uniformly decelerating to a stop at 1/2 meters per second squared. Here, this is also our gradient. If you are decelerating, that means your gradient is minus 1/2. Okay, so that means down 1, right 2. Right, so down 1, I'm going from 8 to 7 here, and right 2. Notice that each box for your x value represents 2, right, 2 seconds. So that means if you go down 1, right 2, your next point will be here. And if you draw the whole thing very precisely, you realize that I actually also come to stop at 60 seconds. Right, so that's what it looks like. So that's it for part A. Okay, we're going to start answering questions for B, C, D, and E. For part B, we're going to use a graph to find who wins the race. Now the problem is, in this case, we actually don't really know where they are. Right? This graph doesn't really tell you that they're going back to the origin at 60 seconds. No, it only means our speed goes down to 0 at 60 seconds. Well, of course, if the speed goes down to 0, that means they stop running. That means they're done. Okay, you see that they're actually done at the same point of time. So that means, theoretically speaking, we can suggest that they are actually tying the game. Okay, but if you really want to show the math, I personally would do this. Okay, so for Sasha, if we want to find out the total distance traveled, we will try to find out the whole area under the trapezium. So the top base is 40, right? Remember from 6 seconds to 46 seconds, so that's 40. The bottom base is 60 seconds. And then if we multiply by 8, that's a height, and divide by 2, that's going to give you the total distance traveled. Right, so this is going to give us 400 meters. So that means by the end of 60 seconds, she would have traveled 400 meters. For Kim, we can do the same thing. The total distance traveled will be the area of the other trapezium. Okay, now the top base is from 4 to 44, which is also 40. The bottom base is also 60, because she stops at 60. Our height is also A, we also divide by 2. It turns out that it's exactly the same, so 400 meters traveled. So both of them traveled 400 meters at the end of 60 seconds, so that shows that we're having a tie over here. Part C, what was the mean speed for each runner? I guess from part B, we can easily answer that because they traveled the same distance, 400 meters. We can have total distance, 400 meters, distance over time, right? So over time, 60 seconds. So our answer is 400 over 60. The answer is approximately 6.67 meters per second for both, okay? For both Sasha and Kim. Part D, if we answered part B already, part D is supposed to be easy to answer. So over this amount of time, we should see that they both ran for 400 meters. Okay, so 400 meters for both. Now part E is a harder one. Who is in the lead after 100 meter and 300 meters? Okay, I'm just gonna focus on part 1 only, okay? So part 2, I'll leave that for you as exercise. It's pretty much the same thing. So how do we do this question? Well, what we're gonna do is, because we can figure out where they are right now, okay, this VT graph doesn't really tell you where you are. Right? But the area under the curve will be able to tell you where you are at what point of time. For example, if you want to find out where they are by the end of 30 seconds, then all you need to do is just find out the area all the way here. But now, we don't know how many seconds by the time both of them run to 100 meters. Just because they started with different velocities, we don't actually know that whether they actually reach 100 meters at the same point of time. So we don't know actually. Okay. So what I'm gonna do is I'm gonna imagine a certain time called x. Okay, I don't know what that time is, but I want that time such that the area under the red trapezium bounded by the red lines that we saw, and x, such that the area under this graph happens to be exactly 100. And I'm gonna solve for that x. Okay, same thing. I'm gonna solve for the x for Sasha as well. Sasha is a little bit flatter. Okay, I'm exaggerating over here. I also want to find this x so that I get 100 as well. Right, so I want to do that for both of them. Notice that in this case, even though I put the same letter x over here, but the x could be different. Okay? It doesn't. We're not sure whether they actually take the same amount of time to reach 100 meters. Okay? They take the same amount of time to reach 400, but we don't know what happens beforehand. So let's figure out the dimensions over here. The dimension over here is, the top base is, because we're turning at 4, right? So that means the top base is x minus 4. The bottom base is x. The height is 8. Okay, here the top base is x minus 6, it's narrower. The bottom base is x, the height is equal to 8. We can use that to solve for our distance. So Sasha, the area under the curve is top base x minus 6 plus bottom base x multiplied by 8 divided by 2. Okay, not pretty complicated actually. We actually end up getting 2x minus 6 multiplied by 4, and we want that to be equal to 100, right? And then we will solve for x for that. I'll put that aside for now. Kim, on the other hand, we also get exactly the same thing. Okay, pretty much the same. X minus 4 plus x times 8 divided by 2. The only difference is I have 2x minus 4 for now. And I also want it to be equal to 100. As you can see, in this case, we definitely have different x values. Okay, so here you basically have, the first one you have 2x minus 6 equals to 25. Second one you have 2x minus 4 equals to 25. Right? So for each one of them, the first one you get x equals to 15.5 seconds. Second one you get x equals to 14.5 seconds. Okay, as you can see, it actually takes Sasha longer to reach 100 meters than Kim. Kim only takes 14.5 seconds to reach 100 meters. So in this case, your answer will be Kim is in the lead after 100 meters. The next question I want to go over is this question on your booklet. Not because it's very complicated, but because I am not sure where I missed, because my answer turned out to be different to the answer that is on your booklet. Okay, so let's go over that together. If you caught any mistake that I made, please let me know, because I keep getting a different answer to the textbook, right, and see if you agree with me. Right, so part A, find the distance traveled for the first 50 seconds. So what I do is I put a line over here, so this is 50, right? And then that means I want to find the area over here. So that's a trapezium again. The top base is 30, okay, from 20 to 50. The bottom base is 50, from 0 to 50. And I multiply by 10, which is my height, and I divide it by 2. Okay, I get 400 meters. That's agreeing with the textbook's answer. So far so good. Let's move on to part B. Part B, we want to find the total distance traveled. So I will include this green part, but also I will include all the blue parts over here. And that consists of the smaller triangle on the top, and then the smaller rectangle on the bottom. Okay, so the smaller triangle on the top is base 30, height 10, divided by 2. And plus the rectangle on the bottom. We have base 50, height 10, and then we plus the 400, which is from the green part in part A. And all of that is going to give me, this is 150 plus 500 plus 400. This is going to give me 1,050 meters. But then this answer is not agreeing with the answer key on the back of our booklet. So help me check and see if you actually agree with me, or if you actually notice I missed anything. Part C, just because we got a different answer for part B, we end up getting a different answer as well for part C. So what I did is I will have 1,050 meters divided by 100 seconds. Okay, in this case, I will get 10.5 meters per second. Okay, whereas the answer from the back of the textbook got 9.75. Okay, that's let me show you the textbook's answer. Okay, the textbook's answer is, this is 175. They got 175 somehow. I don't know why. Okay, and then they use that to divide by 100, so they got 9.75 meters per second. So that's what textbook's answers. Part D, we want to find the acceleration at t equals to 80 seconds. That means we will actually want to find the gradient at that point of time. Okay, because in here we are increasing our velocity constantly, so it's very easy to find the acceleration, which means it's very easy to find the gradient over here. So the gradient of a line is just equal to the rise over run, right? So the rise is 10 and run is 30. So I got approximately 0.33 meters per second squared. But then the textbook got 0.4 meters per second squared. Otherwise, that's it for today. I'll see you guys in the next lesson. Peace.